Hi friends, welcome back to LGF. So today we'll discuss about the problems. We'll solve only problems. But before going to start today's session, I'll discuss about the last time I gave one problem to you people and asked to find out the steady state error in that. The transfer function for that particular system was given with 1 divided by s square into s plus 4 into s plus 10. Okay. I think many of you have solved it successfully. But as I told you, there is a chances to get 99% answer will be wrong. Why I told like this earlier? Because this system is unstable system. The system is unstable system, and we discussed earlier that the steady state error is only defined for the stable system. Stable system, it should be closed loop also. And unity feedback, correct, this unity feedback is for our calculation. Okay, so this is not mandatory condition, but these two are the mandatory condition. The system should be stable, error will be defined for the stable system only, and the system should be closed loop control system. So this system is the unstable system, so we can't find the steady state error. Now you will ask how I'll find the system is unstable system. When we'll come to the third unit in the stability, we'll discuss about this function there. Okay, so please note one point over here, and the point is, if any system in any steady state error question, one of the options is given not defined. Okay, you got one question in that you have 4 options, and out of those 4 options you have one not defined. So please check system stability. Okay, then if system is stable, then only find out the steady state error. If your system is unstable, you have to answer that particular one that is not defined. Okay, you'll be having 4 options A, B, C, D. If D is given not defined, so your answer will be not defined if the system is unstable system. So I hope it's clear to you, correct? So the conclusion is, for this question, whenever you'll get this condition, you have to find the stability first. If directly you will start your question from this, you will get the wrong answer. Definitely you'll get the wrong answer, and wrong answer will be there in the options. Okay, so let me start the today's session. The first problem of the day, this is the GATE 1 mark problem, and in the year 2017. The problem is, so here is the question given. This is the GATE 1 mark 2017, and the question is, wait a minute, open loop transfer function given s plus 1 divided by s to the power p, s plus 2, s plus 3, where p is an integer and feedback is unity feedback given. Two conditions are given for this question. Steady state error is 0 for unit step input, and steady state error is 6 for, here it's unity ramp or unit ramp, correct? And he's asking the value of p is. Okay, so here the p denotes the type of the system or not. Tell me. If type is greater than input, so you will get 0. In this case, your input, if your input is unit step over here, and so type is 1, and for the unit step input is 0. So definitely you will get 0. So this condition, this p should be 1 or not. But this p may be 1, 2, 3, whatever. But let's check the second condition is also given. The steady state error for the ramp, you are getting some constant. When it is possible, when type will be equal to input. So for the ramp, input is 1, type is 1. So you are getting some constant, correct? So this p will be strictly 1 only. Value of p is 1. Okay, so you can check whether you are getting 6 or not. If your input is rem, what is the steady state error formula? If you remember, that formula is limit s tends to 0. Okay, forget about this. The direct formula was A divided by kV, correct? Where kV you know very well. A is unit step is given 1, kV is limit s tends to 0, s into gs over here, s to the power p, s plus 2, s plus 3. So this should cancel to this. You will keep 0 over here, you will get 6 your answer. So p should be 1 strictly, correct? So answer is 1. So this is hardly 30-second question. Immediately you will get the answer for this. Okay. So let's come to the second problem, and the problem is gs is given over here. This is a square and this is 2s. Okay, this is 2 marks problem. Gate 2017, 2 marks. Okay, so here is the system block diagram representation is given. K in series with or cascade with gs, y, like this. The step response of the closed loop system should have 2 conditions are given. Ts settling time, this is the settling time given. The settling time should be minimum and no overshoot, 2 condition. So for these 2 condition, what is the required gain k? This is the value k they are asking for, correct? So friends, please observe this question, then find out it. It will take hardly 1 minute. See, you have to keep your settling time minimum. You have to keep your overshoot no overshoot. When you will get no overshoot? In 2 conditions only. If you will keep zeta equal to 1, this is the critically damping, there will be no oscillations, no overshoot. Or zeta may have greater than 1 also, this is the overdamped system. In this case also you will not get the overshoot. In this case also, this is the underdamped system, you will not get the your oscillation or overshoot. Okay, so which one will choose? Again, one condition is given, that settling time should be minimum. So in the critical damping, the settling time is minimum or less than this settling time of this overdamped system. Actually, the output of this or output waveform for this 2 system will be like this. See, this is for the critically damped system and this is for the overdamped system. So this overdamped system will take more time to settle than critically damped system. This is critically damped, this is overdamped. So here TOD, if you'll find out, is more than this TCP, correct? Critically CD. I hope it's clear to you. So according to your conditions, you have to keep critically damped system. This is not under damped, this is critically damped system under consideration. And for the critically damped system, your zeta should be 1. So this is the system given, k multiply with this. So overall here you will get k a square 2s unity feedback system. What will be the closed loop transfer function? It will be 1 plus k a square plus 2s. Okay, so finally you will get k s square plus 2s plus k. Okay, so this is the second order system. Now easily we can compare this with the standard format. If you remember the standard format, omega n square s square plus 2 del omega ns, this is zeta plus omega n square. Here omega n, when you will compare this, you will get omega n is nothing but under root k. Now 2 del omega n or 2 zeta omega n is equal to 2, this 2, correct? So this will cancel out. Zeta is nothing but 1 by omega n, and your omega n is nothing but under root k. Okay, so it will be zeta equal to 1 by root k. Now what is condition? Your zeta should be 1. If your zeta is 1, what is the k they are asking? So when you will keep 1 over here, you will get k equal to 1, correct? So this will be your answer, k equal to
1. I hope it's clear to you. So problem is given, GS is given. This is the open loop transfer function of a unity feedback system. Okay, always consider the unity feedback system. You have to find the k value if your zeta is given. Okay, everything is given. This is the silly question. You can do it, but do it in 45 seconds. Okay, you'll get answer k equal to 400. I hope you'll do it. Okay, now let's come to this problem. This is the problem. Okay, wait, this is the gate 94 problem. 94. Okay, so problem says this is the first order system given whose transfer function is 1 divided by s plus 1 is excited by input is given 10 sin t, and he's asking for the steady state output. Some students will confuse in the what is this steady state output. Steady state output is nothing but the output of the system after a long time, correct? So the system is given with you. Your system is s plus 1. To this system you are applying 10 sin t, and you have to take the output from it, and we discuss about this. The output will be 10a sin omega t minus or plus minus phi. Okay, this a magnitude is provided by the system, this phi, the phase provided by the system. What is this a, what is this phi? So for that I have to consider this transfer function. Transfer function is given s plus 1. First I'll find the magnitude of transfer function. Magnitude of this transfer function will be under root omega square plus 1, and when you will find out the phase of this, it will be minus this tan inverse omega. Okay, now you have to find your m. Your omega is given over here. Your omega is, this is your omega equal to 1. So you'll keep omega equal to 1 over here to find out this magnitude. This will be 1 plus 1. So you got under root 1 by under root 2 over here. Now let's find the phase. The phase will be minus tan inverse 1. So this is 45 degree, correct? Or in other words I can say this is minus pi by 4. So everything is clear to you now. Now you will find out the answer. So this 10 you will multiply with 1 by root 2. So this will be 10 by root 2 sin omega t. Omega is 1 as it is, minus, you are getting in minus, so you will minus over here. This is pi by 4. So which one is the correct answer? This one is the correct answer, correct? Now let's come the fifth problem. GS is nothing but 1 divided by s square plus 1 has 0 initial condition. You have to find the percentage overshoot in its step response. Means your input is unit step. Okay, so whatever response you'll get, you have to find out the percentage of overshoot, correct? So if you are interested to find out the percentage of overshoot, you need zeta. Is it okay? So first convert it into the closed loop transfer function, so easily we can compare with the standard one. So the closed loop transfer function will be 1 plus GS. This is the unity feedback system given, right? Given in the question. 1 plus GS, that is square plus 1. So, and when you will keep this over here, you will get a square plus 1. This is your output you will get over here. So when you will find out your S will be plus minus J. So this system is the undamped system, correct? Marginally stable. So for the undamped system, what is the zeta? Zeta is 0. Okay, I think you remember this. In the case of marginally stability or undamped system, we got the value of poles plus minus J, means on the imaginary axis. So in this case zeta is 0. So if zeta is 0, so percentage of overshoot, 100% overshoot you are getting. Is it okay? So your answer is 100%. If you want to put these values in the formula, so the formula was e to the power minus zeta n pi 1 minus zeta square into 100%. Correct? And the percentage, so e to the power 0 into 100, so this is 100%. So you are getting 100% oscillation. So the answer of this question is 100. So they asked in the percentage, so you will write only 100. I think it's clear. Let's come to this. The transfer function of the system is given, is excited by sine omega t. The steady state output of the system will be 0 at 4 options are given at omega equal to 1 radian per second, omega equal to 2 radian per second, 3 or 4. Correct. So transfer function of the system given. Okay, your system transfer function to this system you are applying sine omega t. Now they are asking when the system will be 0, at what frequency the steady state will be 0. The system is given by this, you are going to multiply this to this system. Correct. So when we'll get the 0, when this part of the system will be 0, if numerator is 0, definitely output will be 0 or not, tell me. When numerator will be 0, when a square plus 9 will be 0. So omega equal to 3 radian per second. Correct. By solving this you will get this. If you will compare this to, so j omega plus 2, j omega equal to minus 2, it's negative, you are getting, frequency is not negative. So this is not correct. Correct. So this is the correct one. Now why I am doing directly, we have the standard formula that the transfer function is given, the steady state output will be, what will be the steady state output? I'll find steady state output will be a sine omega t plus minus phi, where a I'll find out by this transfer function, magnitude of this transfer function at this frequency. Okay, you will find out, no problem. You'll find out the phase also, but see, whatever input function is given, you are getting at the output also the same thing. This same thing having some changes, the changes provided by the system. The system properties are not going to change. The system is going to multiply with this and will give the sinusoidal output. So this system will be 0 when? If system will be 0 at omega equal to 3, your input you are going to multiply with 0, you will get 0 output or not. Okay, so this is very simple. So let's come to this problem. The unity step response, unity step they are asking. Let me change the color. Unit step. This is not unity, it's a unit step response of a negative feedback system with open loop transfer function. This is given. Open loop transfer function is given, and I have to find out the response. You have given with the 4 options also. So this is kind of your system, that is 6s plus 5. Okay, the closed loop unity feedback minus like this. Okay, here I'll get ys. To this system I am going to apply 1s, means 1 by s, that is the unit step input. I have to find out the ys over here. How will solve this? Find out the transfer function, overall transfer function of this system. So it will be 6s plus 5 and s plus 5, 1 plus 6s plus 5 into 1. So finally you are getting over here 6s plus 11. This is the closed loop. To this closed loop you are going to apply your input, and that is 1 by s.
you want to get your output. So definitely in the frequency domain, ys is nothing but rs into transfer function. Correct. So your rs is 1 by s, your transfer function is 6 divided by s plus 11. Okay, so in the time domain they're asking, so convert this entire signal, this entire output in the time domain. You have to take the partial fraction of this, so you'll get 1 by s plus 11. So to solve this, keep s equal to 0 over here, you will get 6 by 11. Keep s equal to minus 11, you are getting here 11. Okay, so 6 by 11 is common, 1 by s minus 1 by s plus 11. Take the time inverse Laplace of this, 6 by 11, you will get over here 1 minus, this will be e to the power minus 11t. So this is your yt. So option D is correct. Okay, so this was the 2 marks problem, actually get 11 problem. So friends, wait a minute, this is the 2 marks. So hope you enjoyed this session. Please mention in the comment. We'll get some more problems in the next video, and we'll meet in the next and discuss the problems only. Okay, so for new update you can subscribe the LGF. You can find us on the Facebook for doubt solving. We'll meet in the next. Till then, take care and bye.